Alright, so hello and welcome to the debugging point. In this video, we'll be talking about pointer arithmetics. Alright, so before discussing about pointer arithmetics, let us first basically think what would be the size of each pointer. See, pointer stores the address of variables. We already know that from our previous videos. So irrespective of the fact that which kind of a data type it is a pointer to, let's say for example we have a pointer to an integer, a pointer to an integer star, a pointer to void, a pointer to bool, a pointer to double, or a pointer to any other data type such as long. Irrespective of the fact that it is a pointer to any variable, what it has to store, it has to store the address. Since address is of the same format and it does not really depend upon the data type, hence size of all these variables will be same because it has to store the same type of data type. So it will require all of them would require the same amount of memory to store the address. Alright, so let's try and run this piece of code. It's compiling. So the answer is C. The size of each of the variable is 4 bytes. Alright, in most of the compiler it is 8 bytes, but mine is a little old version, so it is showing 4 bytes. However, in your PCs most probably it would show 8 bytes. Alright, now moving on to the concept of pointer. C, here it is written, a pointer has to store address. Since address is of the same length and same format, therefore the point size of the pointer of any data type would be absolutely the same. Now let's say you are given, let's see line number 15. All right, so line number 50, on line number 15 we have int I is equals to 10 and int star p is equals to ampersand I, which means that I is a variable of type integer and p is a pointer to that integer. Alright, it is storing the address of that variable, so p points to variable I. Now if we see out p, we will simply get the address of I. But what if we do p is equals to p plus 1 and then we print it? That is, what if we increment our pointer? So see what can happen here. Let me tell you about the possibilities. See, let's say pointer p is pointing towards this 4 bytes of integer variable. Alright, let's say this is an int variable, it is of 4 byte and it starts from some hypothetical address. Alright, 1a. Alright, ending with 1a. Let's say we have 0x something 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 something, and then at the end last two digits are 1a. Likewise, so see, there are 4 bytes of memory for allocated to this end. Alright, so this 1a would be the starting first byte, address of the starting first byte. Alright, when we do p plus 1, there is a possibility that it will move 1 byte ahead, but this is not what actually happens. Most of the people think that it moves by 1 byte, but that's not true. It actually moves by 4 bytes. That is, if it was on 1a, then it comes on 0x whatever was that value, something something something, and then 1a plus 4 equals 1e. See, on doing plus 1 to a, it becomes b, then c, then d, and on adding one more it becomes e. Right, remember that these are hexadecimal numbers. All right, so they have 0 to 9 and then from a to a, b, c, d, e. All right, f. Alright, so they will have up to f. Alright, so the point that I am trying to make here is that on incrementing p, it does not really move by 1 byte, rather it moves to the next memory location. It moves to the next memory location. See, integer is of 4 bytes, we know that. That's why P moved to next memory location, which means 4 bytes ahead. If it would have been, let's say, a long integer, then this would have been an 8 byte memory. Alright, so P would not have moved 4 bytes, it would have moved 8 bytes, because on incrementing a pointer, it moves to the next memory space. It moves to the next memory space and not really to the next byte. Alright, if it would have been a character, if it would have been a character pointer, let's say it's a character, P is pointing to this. Since character is of 1 byte, therefore it would have moved 1 byte in this case. But what actually pointer does is that it moves to next memory location. Now that memory location depends upon the type of pointer it is. If it is an int type, then it would move 4 bytes ahead. If it is long type, then it would move 8 bytes ahead. If it is a boolean type or a character type, then it would move 1 byte ahead. Alright. So this is what actually happens. See, if we have two variables, alright, so let's say P is a pointer to an integer which is starting from 0x1a address, and it is a 4 byte. Since it is an integer, so it is a 4 bytes of, it has a 4 byte size. The next memory location logically would be 1e. So if I increment P, it moves to 1e. It moves to this memory location. Alright, if we increment the pointer P, let's say we have two variables I and j. So it is not necessary that we, I'm sorry, I have to add an e here, sorry. So if we have two variables in our code, then it is not necessary that the compiler has allocated memory side by side. Let's say we have two variable I, so I is allocated here and j is maybe allocated memory in some altogether different location. Not necessarily, it might not be necessarily present next to I. Alright, so on incrementing I, we do not really know that the memory location we have reached is a memory location which is accessible, which is readable. Alright, we do not know what this memory location actually is. We are completely unaware of this memory location. Alright, it might be useful to our very own operating system, and we might overwrite it. So there might be a program crash in our case, or maybe some system failure. Alright, so we do not really know where have we landed on incrementing a pointer to a variable, except for one case. There is only one case when we know that the next memory we know about the next memory location, and that is array. In no other case other than array we know about the next memory location. See, if we have an array ARR, alright, so this is of this form in general. Let's say if P is a pointer pointing to the first variable, pointing to the 0th index location. Alright, so this is a 4 byte memory. It's a 4 byte memory. Alright, this is also a 4 byte memory since it is an integer. It's a 4 byte. Let me write by for byte. Alright, it's a 4 byte memory. P is pointing to the 0th index. So on incrementing, we'll know that we have reached index number 1. So we are accessing A1 memory. Alright, on incrementing it again, we know that we have reached A2 memory of the array. Likewise, on incrementing it I times, we know that we have reached AI memory of the array. Alright, I hope it is clear to you. So it would make sense incrementing and decrementing would make sense only and only in case of arrays. Likewise, we can decrement it as well. Alright, so if let's say p is pointing to a of 2, a is the name of the array, it's not arr, I'm sorry, it's a. So if we have an array a, so if we are at a of 2, which means second index, then a minus p equals p minus 1, that is decrementing p by 1, we will come back to a of 1. Again decrementing it, we will come back to a of 0. I hope it is clear to you. Like incrementing and decrementing, we can also perform comparisons of two pointers. Let's say we have a p1 here in the array, and another pointer p2 is pointing to this index. Let's say pi is pointing to ith index and p2 is pointing to some jth index of the array. So we can also perform comparisons like p2 greater than p1 in order to know if index j is greater than index I or not. This is just to check if which pointer comes before and which pointer comes after. Now let's move on to the code. It's a small code, and see, we have p. When we increment p, since if we know that integer is of 4 bytes, so it will move ahead by 4 bytes of memory. On decrementing, it will move back 4 bytes, so the original position, the original memory actually will be recovered. Alright, let me just comment this for a minute. Now let's try to run the code. See, these 4s are for this size. Alright, see, originally p was 0x6dfee8. Alright, on incrementing it on incrementing pointer p, it moves 4 memory locations ahead. Alright, so it becomes 8 becomes 9, 10, 11 and 9, 10, 11 and 12, which is 9 A, B, C. Alright, so it becomes EEC, and again on decrementing it, let me zoom it for you. On decrementing it, it again becomes E8. Alright, OX6DFEE8. Alright, so I hope this is clear to you. Now we can also see this for double pointers, but since we know that double pointer is of 8 bytes of size, so it will move by 8 memory locations ahead. See the last line, ptr is a pointer to double variable, and originally it was d8. On move, we have incremented the pointer plus plus, it becomes from d8 it becomes e0, so 8 becomes 9 a, b, c, d, e, f, and then plus 1 e0. Alright, so d8 becomes e0 and it has incremented by 8. Alright, I hope you got this concept very well. Thank you so much.